as previously mentioned, 8.5 is a pretty long section, so we're going to only do a piece at a time. And right now, I think we all understand how to factor out the GCF, and that's the only part of the homework that we're doing right now. But the next time we meet, we'll move on to factoring by grouping, and you'll be able to do the rest of this worksheet. So what we're going to be doing right now is 1 through 12, but don't scratch out the rest. Don't be like, oh, we're going to work on the rest next time we meet. All right, so we'll do 13, 14, 15 later on. But right now, let's just focus in on the first part of section 8.5, which is factoring out the GCF, okay, using distributed property backwards. So on this video, I want to go over the even ones. You guys are going to do all of them, 1 through 12. Always start by putting the parentheses and thinking what's in common in both terms. So what's in common in both terms here that I could pull out? There's definitely the number 4. Is there D's in both terms? No. So all I could do is pull out a 4. So if I do pull out a 4, what's going to be left on the inside right here? D to the second. So we put D to the second right in there. And 4 times what is 16? Positive 4. Now, if you look at the back side of your worksheet, the answers are not there because this is a really long worksheet. So where could you get your answers at? I don't know if you found out, but if you look at your notes, Enrique, if you look at your notes, on the back side of your notes, you have all the solutions to this entire ginormous worksheet, all right? So you could always check your answers, but they're not on the back of this worksheet, they're on the back of the notes. Let's move on to number 4 here. We have 2 terms. We're going to pull out whatever's in common in both terms. So how about that 15 and that 30? What's the number I could pull out?
15.
Some people say 5, but 15 is the greatest, so let's use the greatest, 15. How about the variables? Is there A's in both terms? Yeah, what's the greatest amount of A's I could pull out?
1.
Just one of them, so we put 15A. Is there D's in both terms? Yeah, D's in both terms. What's the greatest amount of D's I could pull out from both of them at the same time? 1D. So our GCF really is 15AD. If I do pull out 15AD, in other words, if I go 15AD times what will get me that first term 15AD? A simple 1. You need that 1 right there. Let's put a plus. 15AD times what will get us a 30A squared D squared? 2 AD, right? Now, let's pretend that we just said 2. And you try to check your work here. When you go 15 times, well, first of all, 1 plus 2, that would be a 3, right? And that wouldn't give you the above. So you know you need an A squared. So A times what gets you an A squared? That would be an A right there. And D times what would give you a D squared? That'd be a D right there. So there's your final answer for number 4. Let's move on to number 6. Put the parentheses. What's in common in both terms, in the 36 and the 48? The 8? No. The 6? 12? I'm getting good answers here. That's good. What's the greatest common factor?
24. I don't know.
No, not 24.
9.
12. 12 seems like a good number, right? I mean, if you think about it, 36 is divisible by 12, and 48 is divisible by 12. I mean, 4 would work, but that wouldn't be the greatest. 6 would work, but that wouldn't be the greatest. So let's go with 12. The greatest. And how about, are there X's in both terms? Yes. I want to pull out one of those X's. And are there Y's in both terms? Yes. What's the greatest amount of Y's I could pull out? 1 single Y. So I have 12XY as my GCF. So 12XY times what will give me a 36XY squared?
3x.
Definitely a 3, but you also need 3y. Okay, no x's, right? Because think about it. When we go 12 times 3, we get to 36. You could do it piece by piece, right? 12 times 3 is 36. X times what will give me an x? You could put a 1 right there, but that would be pointless because 3 times 1 is still going to be 3. And then y times what gives me a y squared? You need a y right there. Y times y gives me a y squared. Okay, now how about 12xy times what gives me the negative 48?
4x. Negative 4x.
Negative 4x. And that's all I need, right? Once again, if you go through the piece by piece, 12 times negative 4 is negative 48. X times x is x squared. Y times I mean, you could put a 1 right there, but that's pointless because 4x times 1 is simply 4x. You don't need this times 1. And that's it. Let's jump to number 8. 2 terms, parentheses. How about those numbers, 9 and -6? What could I pull out? 3. How about those variables, A's and D's? How many A's could I pull out from both at the same time? 1 A. And how about those D's? 2 D's, right? There's a D squared and there's a D to the third. So there's 2 here, 3 here. The maximum amount of D's you could pull out from both at the same time is D squared. So D squared. So you have 3AD squared. What's left over on the inside? In other words, 3AD squared times what gets you back to this? 3. Okay, so piece at a time, 3 times 3 is 9. A times what is A to the third? A squared. And how about, do I need any D's right here? D squared times something, give me D squared.
3A.
No, it's 3A squared minus 2D squared.
Okay, so I could put a 1 right here, but that would be pointless because anything times 1 stays the same. Let's move on to the second part. 3AD squared times what gets us this? Negative 2. D. And that's it. Piece at a time. Check it out. 3 times -2 is -6. A times what gives me A? A times 1, but I'm not going to put a 1 there. It doesn't do anything. And then D squared times what gives me D to the third? D squared times D gives me D to the third. Number 10. Parentheses. What's in common? 8, 24, and 16. 4? 8. 8 is the greatest value. So let's pull out the 8. How about those variables? Is there a P in all 3 terms? Yes. What's the greatest amount of P's that you could pull out from all 3 terms? 1. So 8P is our GCF so far. How about R's? 1R also. So 8PR is our GCF. So 8PR times what gets us an 8P squared R squared? 1PR. 1PR. And you don't even need the 1. I'll leave it there for now. But you don't need the 1. How about 8PR times what gets us a -24 PR to the third?
-3R squared.
-3R to the second.
Yeah.
Good. And how about 8PR times what gets us a 16 PR?
It's just 2. It's
Just 2. Just 2. Positive 2. Let's move on to number 12, the last one on today's homework. So I am going to put my parentheses. I'm going to look at all 3 terms. 9, 18, 24. What's up? What could I pull out? 9. No.
No, you can pull out
9, 8, 3.
3. Like, I mean, 9 works here, 9 works there, but 9 times what is 24? That doesn't work, right? If that were a 27, yeah, I could pull out a 9. So we're going to pull out a 3. Actually, yeah, 3. Let me do this in red. I always do this in red. Are there A's in all 3 terms? No. Are there B's in all? No. X's? Yes. So 3X is our GCF. So now 3x times what gets us 9ax to the third? 3a
3A
x to the second. How about that middle term? How do I get 3x times what gets us an 18bx squared? Positive 6. 3 times 6 is 18. Now I need bx squared, but x times what gets us a bx squared? Well, b with an x. And last but not least, another plus sign. 3 times what is 24? 3 times 8 is 24. X times what will give me a cx? I need a c in there. And that's it. This video has all the even ones. You guys need to do all of them, so go back and do these odd ones. Next time we meet, we will pick up with the rest of these, like 13, 14, 15. 13's awesome because even though it looks like it's not factorable, right? Oh, there's x here, x there, there's no x here. I cannot factor it. You could actually factor it, but using a different method We're going to learn about that next time we meet. Right now, just 1 through 12, guys.